Welcome back, everybody. In this video, we're going to be diving into our next ASA firewall topic, which is going to be referred to as transparent firewalls. Now, transparent firewalls themselves are operationally different and are deployed in a manner that allows them to be kind of put in line, if you will, without having to completely redesign the network. Now, what we're going to be taking a look at here is on ASA v2 right here. We're going to be taking a look at getting him rolled out in a way that allows us to go through and get the ASA to act like a switch. That's really what the transparent firewall is doing. So it's kind of sometimes referred to as what they refer to as a bump in the wire. So what's actually happening here? Well, in the grand scheme of things, it's no longer acting as a router. So if you go from a transparent mode, or from routed mode to transparent mode, then that's a bump in the wire. But at any rate, the idea that we're trying to achieve here is, how do we take a situation where on the edge of our network, so we'll take an example where I have an existing implementation rolled out. Let's say, for the sake of argument, that the connection between R11 and R2 is a public connection, right? And then R11 and switch 2 are it's an internal connection, so it's using a private address space. Well, I need to be able to add capabilities to like for filtering and for management and stuff like that, for monitoring and things like that. But I don't have the ability right now to readdress. So how do I go about doing this? Maybe this could be a public address space too as well. I've seen that rolled out a few times in production. The idea is to be able to place this firewall in between two routed devices transparently. So this would be no different than if you were to, for instance, take a fiber connection between a switch and a router and run a /30 connection between the switch and the router, and that was the connection where the switch was an aggregation point from other parts of the network. So other stuff plugged into that, like maybe this is a core switch, and downstream there's a bunch of access layer switches, and you have a routed connection between the switch and the router, and then the router is your NAT point or something like that. It's terminating the internet from the inside of the network. Well, you need to be able to put a firewall or put some sort of monitoring device in between the router and the switch. The ASA can do that in transparent mode. Now, what we'll do, this is actually a functioning configuration, so we're going to be walking through how to get this up and running when we get there. Now, I've seen this deployed in situations where we have what they call a staggered or a hierarchical public address space. Now, what that means really, and it sounds more complicated than it really is. Let me go ahead and pull my pen pad out here. I have had customers in the past that they will run like this connection here and then this connection here. They'll both be public. So you'll have a public address space up here, and you have a and you'll have a public address space down here. And they might say, well, why would you use either one? Well, the reason why you would use either one is you now have gone from taking this as your termination point, where everything northbound is public and everything southbound is private. When you move away from this paradigm and you move into where you're going to have maybe a bunch of DMZ servers sitting out here doing whatever it is that they're going to be doing, they plug into the switch, they plug into the ASA, or maybe a switch that's sitting behind the ASA or something along those lines. Well, what's going to end up happening is you might not want to have any traffic going through the firewall that might potentially be able to jump from private to private, meaning DMZ with private address space to the inside space. So this would be, in my opinion, another layer of security beyond that, where your public address space is going to be clearly out here. There's no NAT here. There's no way that traffic is going to get back inside. Now you might say, well, okay, how would that play out? How would that work? Well, it's actually not that difficult. I've actually done this for quite a few customers where they've had their first public address block is right here, where they have normally the provider, they go out and they get a circuit from the provider, and the provider says, okay, we'll give you a they order like a /27 for public address space. And they say, okay, so what we'll do is we will, or maybe that's actually, in this case here, I think we already had a /30. But what we're going to do is we're going to say, you know what, that's fine. If you want to keep that /30, don't worry about it. What we're going to do is, normally this would just be a default route from the provider. So the provider would advertise this /30 into BGP, into the internet routing table. And then on this router here, we would just have a default route pointing towards router 2. Pretty standard design. Now, in situations like that, that would work. But let's say we want to take it and now we want to say, you know what? A default route is what we want from the provider. But we don't want to just have a default route we point outbound. We want to actually set up a BGP peering and we want to advertise routes outbound. So this would be, so there's 3 levels of BGP peering that you can have. You can have what they refer to as just the default route. So I'm going to say default route. This would be the most basic. You just have a default route advertised to you via BGP. The next one you have is provider only and customer only addressing. So you might say, well, what is provider only address space? Provider only address space is address space that the provider owns and advertises to you in addition to any address space you want to advertise. So customer owned might be a /24 or 2 or 3, or it could just be a /27, depends on how big of a public address space you have bought and you happen to own. Then the third one is the full table. So regardless of whether you go with options 1, 2, or 3, you need to make that determination. The most common one here is the default route. Most customers that I've worked with, they don't go full routing table unless you're an internet service provider and you need to have that visibility to make routing decisions based off of a given set of information. If you have some sort of behind the scenes software defined networking capability, I'm trying to think of what the one that I saw deployed. A customer that I worked with for a little while had one, and it's escaping me what the name was. But basically, what the technology did is it used NetFlow to calculate statistics, and it would inject routes based off of local preference, based off of NetFlow data. I'm sure somebody's going to be like, "Oh, I know what that is." If you know what it is, throw it in the comments below. I'm sure it'll come to me later on. So the default route is what we're going to go with, or is what this particular customer I helped set up. Now, you might say, why does this matter? Well, this matters because what we ended up having to do was we ended up having to take and all this address space down here that would normally be private turned to public address space. So what we ended up doing was this firewall we turned into a switch because we didn't want to have it tied up with any more address space than what we needed. Now, what we ended up doing was we took the address space that we bought. Well, let's just say the customer purchased it. We took that, it was a /23. So we had a /23 that we had to be able to play with. The address space itself is irrelevant. It was a /23. That's all you should care about. What we ended up doing is we took and we broke that down to 2 /24s. So we had, which the /23 is 2 /24s. So we had the /24 and the /24. What we ended up doing was we ended up taking the /24s and advertising them independently, so that we could say traffic from one side would go out towards, AT&T, one would go out via Time Warner, and we could, or Spectrum, whatever it was, and then we could load balance the traffic based off of given metrics. So there's a little bit of BGP traffic engineering that came into play with this, a little bit of AS path prepending and stuff like that. There's a little bit more to it than that with some routing internally with OSPF and choosing a type E1 versus a type E2, but that was a whole different situation altogether. So what we ended up doing, and the point of this entire video, it ties into why we went with transparent, was this right here was a /24 address block right between here. But guess what? This guy right here only chewed up one IP instead of chewing up two IPs and two different networks. So it's actually one subnet between these two right here, but two different VLANs, or two different bridge groups. I'm sorry. Yeah. So what we're going to be taking a look at here is we are going to be taking and rolling this out in such a manner that as we're going along, let me go ahead and switch back over to my mouse, is if we look here on ASAB2 and I come in here to show interface IP brief, what I end up having is I have two of the same bridge group, right? So it would be, you have the routers would, in most cases, if the ASA was a routed device, so layer 3, you would have some sort of subnet between ASAB2 and router 11, and then another /30 between switch 2 and ASAB2. So it'd be 2/30, so two different subnets. I don't need to do that. I can maintain one subnet and two different interfaces on the firewall. So what I'm going to be doing is I'm going to go through and I'm going to create a single bridge group. In this case here I said BVI 10 because I needed VLAN 10. So what we're going to do, and we're going to walk through the configuration of how this comes into play, because it's not too terribly difficult to get it working. You just need to go through the process of having it up and operational. Now there was some behind the scenes stuff that I had to do, and I'll walk you through what I had to do in order to get this to work. It's just a little bit of routing rigmarole, but I'll explain to you what it is that I did. There is a number of things that come into play with how this actually operates from a firewalling perspective and stuff like that. And we're going to talk about those as we go through here. So what I'm going to go do is, and I don't think I've saved this, we do a show startup config. I don't think I have saved this config at all, and I have not. Firewall transparent. So I will actually go through and let me just make sure that I actually have not. Yeah, so I'm going to go up to here. I'm going to type in the firewall, and here I can say transparent. If I type in transparent, if I type in no firewall transparent, it reverts it back to an ASA. It's just a blank ASA. If I do a show run, now we have the interfaces are all shut down. The firewall is no longer in transparent mode. So what I will do, and this is actually going to break the config. Let me go ahead and pull up PC3 now. PC3 is, if I go to ping Google now, Google's not going to work. Eventually you're going to see the pop-up here show up, and it's going to be like, oh, I have no internet access. Well, that's because of the fact that I just broke the crap out of the network, but I needed to do that in order for to show that it would actually do its thing. So there's a few things that need to happen here, and we're going to go through those steps as we're going along here. Now, as we go through and we start breaking it out, if I go to, let's say for instance, I do a show interface IP brief, and I have all my interfaces are shut down. If I go to, let me go ahead and clear the screen off real quick. And let me go to R11 and switch 2. So if we jump to those real quick, if I do notice how my EIGRP adjacency went down. If I do a show IP interface brief, I have 10.2.11.11, and on ASA on switch 2, I have show IP interface brief pipe exclude unassigned. I have 10.2.11.2. Now, because of the fact that I have these devices here, if I was to change up the VLANing, meaning if I was to make ASAB2 a routed device, that means I'd have to have another subnet, one that would sit between R11 and ASAP2, or sorry, I'd have to. I wouldn't be able to run a subnet between switch 2 and R11. I'd have to add another subnet, so a second subnet, to allow communication between ASAP2 and R11 and ASAP2 and switch 2. That would be all routed. So if I go here and if I go up to ASAP2, I'll change the host name to be ASA2, and I come in here. I say interface gig0/0. Type in no shut, and then I'll say the IP address is going to be 10.2.11.20/24. I'll type in name if is going to be outside, and show interface IP brief, and I ping 10.2.11.11. I can ping it, right? Because that connects me to R11, and gig0/0 happens to be connected to R11. That's why the ping works. Now, if I come in here and I exit out and type in firewall, I type in just transparent. If I hit the enter key, there is 0 warning. So if you're just wondering if there's going to be a prompt and you do this in production, don't do it in production. So it's now transparent mode. Now it doesn't prompt you and it wipes the config. Now the device is going to be in transparent mode. Now there's a few things we have to go through here and do. We have to create a bridge group. The bridge group is going to essentially be a VLAN. So it's going to be the same VLAN with, sometimes it could be referred to as two different bridge groups in the same VLAN, and stuff like that. You could do it however you want to. I'm going to use the analogy of I have a ASA and I have one subnet. I need to be able to use the ASA to connect R11 and switch 2 together in order for them to form an EIGRP adjacency. So host name is going to be ASA2. Show interface IP brief. The interfaces are both down. So I have gig0/1 and gig0/0. And what I need to do is I need to go and I need to make sure that on this configuration that I have it squared away in such a manner that R11 and switch 2 are able to pass traffic back and forth. So what I will do is I will type in interface gig0/0. I will type in bridge group, and I'm going to give this in just a number of 10. Bridge group 10 and 0, and I'll type in no shut, and I will say that the name if is outside, and I will say that on gig0/1 the bridge group is going to be 10, the name if is going to be inside, and the port is going to be no shut. So now I've done that. I type in show bridge group. I have them both, I have them configured, and I have them applied, which means that the bridge group is created. The bridge group is no different than a VLAN. So if you're familiar with switches, you go to the switch, you create a VLAN, VLAN 10, you apply it to two or three different ports. They're all in the same broadcast domain. So what I'm going to go do now is I'm going to go and type in, notice there says BBI interface for this bridge group does not exist. If it does not exist, you won't be able to forward any traffic. So keep that in mind. So what we're going to do now is we're going to go through and I'm going to do a little bit of other configuration that we need to do. So what we're going to have to do is we're going to say interface, and the bridge group has to, the BVI, so interface BVI, and we have to say 10, and I have to give this an IP address, and I have to give this a subnet mask and no shut the port. So IP address is going to be 10.2.11.20/24. I'm going to no shut the interface. Show interface IP brief. Okay, I don't need to worry about shutting it down. So what that now does is that gives me the ability to go out and I have the connectivity now up. So I should be able to go to PC3 now, and I should be able to ping 10.2.11.20. Oh, can't. Now, you'll notice that I can't ping it. I'm not getting a response. So let's go ahead and do this -T. One of the reasons why I can't ping it is if we look here, we do a show route. I don't have a route back in. I don't know how to get to where I need to go. So I need to type in route and say inside, and I need to say for any traffic that I need to route towards, I need to say I need to route internally towards. I could do a default route inbound, but that's not a good idea because then you're basically saying any traffic that comes into you, I want to send back out. But this box is not a routed firewall, so I don't want to do that. I want to be more specific. I want to be specific to RFC 1918 space. So what I'm going to go do is I'm going to type in route inside, and I'm going to type in 10.0.0.0 /8, and I'm going to type in 10.2.11.2. Now, and notice that the ping starts to reply again because I'm sending traffic back towards the switch, and now I've got that connectivity. Now that we have that, now does that mean that I have my EIGRP adjacency back? Show IP EIGRP neighbor? No, it does not. So there's a couple things that you need to take into consideration here. I can do this one of a couple different ways. I can go through here and I can create a we've already talked about the global ACL. So if we were to go ahead and bring this down just a little bit, and I'm going to go back into ASA2, and I'm going to say logging enable, logging console debug. Now what we're going to end up seeing here is you're going to see a lot of, let me go ahead and let me actually cancel this because it's going to gum it up. What you're going to see, let me go ahead and move this over a little bit. Right here, this is what I want you guys to see. You'll notice that I have this deny inbound protocol 88 source inside and source outside. Let me go ahead and no logging enable. What this means right here is that EIGRP from switch 2 to R11 is supposed to be going through the firewall. That is not currently happening. So both from the inside and the outside, it's being denied. Because the way that the filtering engine works a little bit different, both interfaces are now saying, okay, well, I'm denying traffic inbound. So there's one way of fixing that is to go through here and configure the global ACL. So let's go and create an ACL. Type in access list. Access list, we'll type in global. Actually, let me see. Show access list. I'm not sure if I have an access list already configured. So access list global, and we'll type in here, we'll say permit, we're going to permit EIGRP any, right, and that's going to work. Now, now that I've got that configured, I should go and type in access group global, and we'll say global is applied globally, right? And that would make sense, right? So now we have that. Now if we go back to 11, now my EIGRP adjacency is up on switch 1 and switch 2, and there we have it. And if we go back here, or on ASA2, if we do a show con long, we should see an EIGRP adjacency sitting between the routers. And we do EIGRP outside, everything looks good. So we have EIGRP adjacencies up and running. Here's the drawback to doing it this way though. If I go back to here, and one thing I have to do, we do a show run policy map. Underneath here, I'm not permitting ping through. So let me go ahead and allow ping to go through real quick and type in ICMP. And let's go back to here. And let's go on here and hit the up arrow. Let's ping Google again. So we're pinging Google. Let me go ahead and just do a long-term test. And let's go back to here and type in config logging console debug. And underneath here, what we're going to see is we're trying to ping it, and it's failing. Let's try that again. Let's see why we're failing to ping. Any idea? So let's do a show access list. Or I'm sorry, logging enable. That's part of the reasons why it's not working. We'll type in. So what we see is a UDP source is denied UDP source inside going outbound. So if we look at the show access list, we'll see that underneath the access list of global, we're only permitting EIGRP. So that means I'd have to go type in access list global permit UDP any. And then I'd have to come in here and type in ICMP any. And then I'd also have to type in, you guessed it, I also have to type in TCP any. So effectively what I'm doing, if I hit the up there, hit the up in here, if I go back to here and I hit the up arrow, now it's going to go through, right? But what is that done from a access list perspective? I've permitted almost everything you could possibly think of. Let me go ahead and Control C that. And let me go back to here and let's do a show access list. Now you'll notice here that I have EIGRP, UDP, ICMP, TCP. That's pretty much every type of traffic you're going to see on the firewall for the most part. So there's DNS, there's DHCP, there's, pretty much anything related to that. Not a good idea. It's basically what you're doing by using the ACL to permit everything globally, which remember the global ACL applies everything inbound on every interface. I'm basically permitting anything from the outside in, and I'm good to go. I'm not natting anything, so I don't have to worry about that. So this is a bad thing. Really, really bad. Not a good idea at all. So what I would recommend you do instead, if you do a show run access group, is pull this guy out. No access group this. Now what's going to end up happening is after a moment or two, our EIGRP adjacencies are going to fail, and we're going to start to lose connectivity, and you're going to start to see ACLs or EIGRP get dropped, and but I'm okay with that. The reason why I'm okay with that is because there's a better way of doing it. And the better way of doing this is by going through and creating individual ACLs, one per interface. And so here we have a bunch of connections being torn down because UDP is not being permitted through. We're going to see some 88 traffic going back and forth. So the easier way to do this is two different ACLs. An ACL for the outside and an ACL for the inside. We're going to start off with the inside first. We're going to permit the traffic that we want to go through, which is going to be EIGRP and IP. So pretty much anything that's going to go through, we're going to allow that inbound on the firewall. But you might say, well, that's even worse than what you did before. It is, but we're going from the inside to the outside. So we'll allow EIGRP in only. So the routing adjacency between R11 and switch 2 will be able to form again. So as we go back to R11, we'll notice that the EIGRP adjacency here in a moment will be down. If we do a show IP EIGRP neighbors, it will eventually go. Oh, you know why? Because the connection table hasn't timed out yet. Switch 2 eventually will time out. We do a show IP EIGRP neighbor. That connection eventually will go down. And when it does go down, if we go back over here to here, if we do a show con long, we still have connections in the connection table, and eventually that will go down. It'll hit a timeout value, and so we'll hit that, and eventually we'll just die. But I'm going to go ahead and clear the connection table now. I'll type in clear clear con all. So I'm going to clear all the connection tables. So, and if we go back to 11, we will eventually see that the adjacency goes down, and because then the what will end up happening is the there it goes. No, I no longer have any AGRP adjacency. So what I can do now is now I have this connectivity is failing. So now I have to go create an access list on the outside and an access list on the inside that allows the specific traffic to go through. But what you're doing is you're permitting it from the inside to the outside. So the high to low that we're already familiar with when it comes to the ASA will still be in process. So the filtering, so from the low security level to the high security level, that will still be enforced. So what I'll be able to do is I'm going to type in here access list. I'll type in inside in. I'll say extended permit EIGRP EIGRP any. Actually, I made a goofed up that any. And I will also say EIGRP any, and I'll type in IP any. EIP. So if I do a show access list, now I have that EIGRP any and the IP any, which is going to allow traffic to come inbound. So I'm going to type in access list, and it's going to be ACL outside in, and I'm going to type in permit EIGRP any, and that's it. I'm not going to allow anything more specific than that because I just want to allow EIGRP traffic to come through the firewall. I'm going to type in access group, and it's going to be ACL outside in. I'll type in interface outside, and I'll type in access group ACL inside in interface inside. Show access list. Did I name it wrong? Oh, so let me go type in no access list inside in. We'll type in access list ACL inside in permit EIGRP any, and then IP any, and then I'll type in access group ACL inside in interface inside. There we go. So now what will end up happening is there should be an adjacency between R11 and switch 2 now, and there is. The adjacency is back up. However, I go to ASA v2 and I do a show con long. Eventually I will start to, so I have the EIGRP connections going out. If I go back over here to this guy and I hit the up arrow and I ping google.com, that's going to work because the normal ASA firewall capabilities are still there. I still have the ability of doing DNS lookup. I still have the ability to ping. I still have the ability to do a trace route. So if I wanted to go to, say, youtube.com, I should be able to, after a moment or so, I should be able to find youtube.com, and I should be able to resolve it. It might take a couple seconds because it's not the fastest connection in the world, but the point being here is I've allowed the connectivity outbound, and that's the point. We want to make sure that we have that connectivity out there. So if we ping, let's say, ping youtube.com, I can ping youtube.com, and I know I can reach it. Now, because of the fact that I can go out there and I can reach it, and I can resolve the IP, if I look in the connection table, if I do a show con long, I'm going to see a bunch of entries in here for YouTube related content, and that's exactly what I'm looking for. Again, it's going to take a little bit to find it, but if I go to say, let's say Google, that isn't quite as heavy, google.com, Google should pull up relatively quickly as well. YouTube, there's just a lot of stuff that goes into a YouTube's main page. So we'll have Google will pull up a little bit quicker than that, which we knew and we expected. Now, again, this is all transparent. The firewall capability is still there. So we have all of that stuff good to go. Everything looks great. So all of that connectivity is still there. And if I was to do a, let's go ahead and type in no logging enable and turn logging off. Let's just do a show access list. I have the access list in, and I'm permitting EIGRP and any other type of traffic outbound. But that's from a high security level to a low security level. I'm not going through and saying, you know what, I'm just going to throw firewalling to the wind and not care about anything, and there we go. I'm still filtering, right? Traffic from high to low is permitted, but traffic from low to high is not. So in situations like that, if we do a show run access list, I have my ACL that says I want to permit EIGRP between the inside and outside interfaces and allow them to go through. I also want to permit any traffic from the inside going outbound to go. Now you might say, well, from a routing perspective, show route, you're not routing anything. You have a static route pointing inside. Well, that might be true, but that is just for management access. That just allows me to connect to the firewall. That's it. So that's how I'm basically coming through and getting all this stuff squared away. Now, what I can go back through and do, now in the grand scheme of things, if I come over here and I was just type in ipconfig, you would see that I'm a 172 or a 10.100.20.10 address, which is why I have that PC set up the way that I have it set up. I actually removed test 11 and put in PC3 there as for testing purposes. So I could, if I wanted to, I could take this a step above and do some advanced filtering if I wanted to do so. So what I'm going to go do now is we're going to go through and we're going to say, you know what? I want to actually drop YouTube. I don't want to be able to go out to, I don't want my users being able to go to youtube.com or anything like that. Even though it's an HTTPS site, we're going to match on the domain of YouTube, not the URL of YouTube. So we should be able to block the DNS query. So to do that, we're going to have to do a few things. We're going to have to create a regex. So the regex is going to be, we're going to type in YouTube, and we're going to say :youtube.com, double quotes, and we're going to type in here a class map of type inspect, and we're going to say DNS. We're going to match any type of traffic that's coming through it, and we're going to call this a class map of inspect DNS. And we're going to type in match domain name of regex is going to be YouTube. Now, we're going to do that, and I know it's actually kind of very interesting that I'm choosing YouTube when you guys are watching this on YouTube, but that's okay. What we're going to do next is if we've got the class map defined, and we have called the regex from the class map. So now we get to do a show run policy map, and I want to actually map this to this preset DNS map, and I want to place this underneath this one. But I'm gonna underneath the policy map. I'm gonna call, because this is a policy map of type inspect, which is going to be applied to all interfaces. And what I am going to end up doing is I'm going to go underneath here, and I'm going to simply copy and paste this in like so. I'm going to type in class, and I'm going to call the class map of type inspect DNS. And underneath here, I'm going to type in drop connection and log. Now, because I'm doing this policy map type inspect is calling the class map of type inspect DNS, which is matching the regex value for the DNS lookup or youtube.com. But that particular DNS map is being called from the layer 3, layer 4 class map underneath the global policy. So the global policy will read show service policy global of inspect DNS and hit the enter key. What I'm going to be doing is I'm going to be going through and inspecting any DNS traffic that goes out to youtube.com. So now what I should be able to do is I should be able to close this out. Yes, close all tabs. Thank you, sir. May I have another? I'm just going to click back on here on Internet Explorer. I'm going to give that a moment. It's going to go out, and it's not blocking anything else. It's simply blocking YouTube. And what I'll be able to do is I'll be able to come in here and hit the X button for it to stop trying to find what's going on out in the world. And what I'll do is I'll come in here and type in youtube.com and hit the enter key. Now what's going to end up happening is if I hit the up arrow here on this side, you're going to start to see regex values start to populate. So it's dropping the connections as they're going out. So YouTube DNS queries are being sent out but are being blocked. If I was to actually come in here and so it did a Google search for YouTube. Now if I try to actually go to YouTube, that should be blocked as well. But the other thing too is this might actually go through because of the fact that it's HTTPS and it can't read and it did its job. Even though it's HTTPS, the DNS query was blocked. So let's go ahead and try that one more time, but this time I'm going to debug it. So I'm going to type in debug, or let's come back over here to this. Let's come over here to this guy and type in logging enable. So logging is now enabled. I should be able to come back here and I should be able to open up Internet Explorer. And what you're going to see is in here, I'm going to type in youtube.com. And what you're going to see here on the ASA is you should see a lot of inspection disconnected drop packet. This guy right here. It's going at the DNS lookup. It's saying, I want you to go out there and try to find the youtube.com, but inspector disconnected. So it was terminated by the classification flow. So DNS classification drop DNS request based off the class map. So if we go back to here again, if we hit the no logging enable, and I drop out of here and I do a show service policy again, you're going to see another set of hits on that particular regex value. Now this applies to everything. If I want more specific interfaces, I would have to create another policy map. So show run policy map. I have to create another policy map. Right now I'm just using the global one. I'm using the the DNS security one. I'd have to add a DNS map, another policy map type inspect for DNS, and name it policy map, probably PM underscore inspect DNS, and then I'd have to apply that to a specific interface with the service policy. Then that would be blocked for a specific interface. But this is inspecting it globally. Every interface that this ASA is running will be inspected for DNS traffic. So it'll block YouTube for anybody. So that's how that will come into play. Now, in situations like this, you do have to be careful. And remember, this is all transparent. If we do a show bridge group, we see that, I don't know if it goes any more, 10. Yeah, it shows me that I have 2 MAC address entries in the table. There was a BBI, the interfaces that are associated to it, and stuff like that. So that's pretty much what you have to worry about. That's transparent firewall. Everything about the ASA still works from a filtering perspective. The only thing that you have to remember, if we do a show access list, is that you must create an access list. Let me go ahead and clean this up a little bit too. Let me do a show run access list. We'll type in no access list global. Let's actually clear configure access list global. And inside in. So show access list. By having these 2 access lists configured, what this basically is saying is I want to allow EIGRP in from R11 and only EIGRP in from 11, and that is explicitly being permitted through to allow the EIGRP adjacency. That is it. Now, let's talk a little bit about what I had to do on the routing side in order to get traffic to go towards ASA2 and all that good stuff. Break some of that down so that in case you guys have been following along from the beginning, you're not going to be like, how'd you make that work, Rob? So basically what ended up happening was, and I did mention when I first started doing this series, that the configuration might change it a little bit. So what I ended up having to do was I ended up removing, I kept the ASA and I just had to add in another router. That router allowed me to do the routing between through the firewall itself. And then what I ended up having to do is on ASA v1 is I went and I did a show interface IP brief, and I shut down the I shut down an interface, I believe. At least I thought I did. I did something somewhere. I forget where I did it. Oh yeah, I shut down the outside interface. So this outside interface, and the reason why I had to do that is because I was getting a default route. If I scroll up here, I don't know if I'm going to be able to find it because it's been probably a week since I've done it. Yeah, see that those syslog messages are going to mess me up. But basically, if we do a show route, I was getting an OSPF default route originally from R1 because of my configuration, and I wanted to choose EIGRP, but the drawback to EIGRP external routes is they have an AD of 170, and that is not going to be an OSPF E2 type external route. 110 is the AD, so I basically shut down the interface of ASAV1, redirected all my traffic this way, and I just did some basic routing. I just said turned on routing on switch 2 here. If I go to switch 2, I do a show IP route. I have routing configured between switch 2 and switch 1. I do a show IP EIGRP neighbor. I have a connection with 172.16.30.1, which happens to be ASAV1. And that goes through. So basically these guys are all transparent switches, so just doing layer 2 operations. And so switch 2 has an EIGRP adjacency with ASAV1. PC3 is default gateway is ASAV1. So ASAV1 then routes the traffic back out towards ASAV2. So think of this like an ICMP redirect type of operation, where could I have just gone directly to ASAV2? Sure. But there might be a situation, and I'm just thinking hypothetical here, that you might have to resort to some advanced routing capabilities. And this really is nothing advanced. All I did was I shut down this outside interface and allowed the connectivity to go through the way that I needed it to. So that's basically how this comes into play. So there is a little bit of tweaking a little bit of tweaking that needed to happen in order to make this all work, but eventually it did. I was able to get my default route from the router that I had going, and once I did that, the routes all showed up the way that I needed it to, and R11, in case you're wondering, show IP interface brief, does have a public IP address on it. We're simulating it, and I'm natting. So show IP NAT translations, and you'll see a bunch of NATs going through. So I am natting on this router here, and then it's being natted again on my home router and stuff like that. So that's basically how all this stuff is coming through. So it's slow because it's going through virtual routers and firewalls, and it's slow on purpose. But that's basically how this actually all comes together. So that's basically it for transparent firewalls. ASAVs don't support multiple context mode or active failover. So that's why I have ASA3 and ASA4 over here. These are ASA VMs. I will be testing a multiple context mode with you guys in an upcoming video and talking about how that works. And then we'll talk about active. And matter of fact, let me just see where I'm at with that. I still have some NetFlow to do, and then we have a multiple context mode comes up here in just a moment. That'll probably be the next video, and then we have the active standby. I'm sorry, active failover, I believe is what I do next. there's a lot going on. Yeah, it's active stateless and active stateful failover for this configuration. There's a lot that goes into it, so it's going to take us a little while to go through that. We're going to do multiple context mode in one video, then we'll do the failover in another video after that. If you have not seen the blog post, I recommend you check out the blog post because I do a lot of testing in this stuff. And then once that is done, there's really not much more to it than that. There is there's clustering, as I think is the only other topic that I have not covered yet for ASA, for firewalling. And that'll pretty much cover everything, but I'm not going to do that just yet. I still have to test that out a little bit. And I think that's outside of the realm for CCNP security, but at any rate, that's pretty much where it sits. We'll be covering that when we get to it, but we still have some NetFlow to cover, and once NetFlow is done, well, multiple context mode, failover, and then probably NetFlow, and there'll be probably some miscellaneous topics that I throw in there just because of the fact that I want to do them, and go from there. If you're still watching this at the end of this video, so we're almost an hour in. I will be doing some service provider material in the near future. I'll be coming out with a bunch of stuff on service provider. As a matter of fact, on here, I will go ahead and pull it up. There is a, let's see here. Let me go to longest match.weebly.com. Here is my new website, and this basically is going to be a site that anybody can use, and basically the idea here is it's going to cover every technology that I decide to cover. So I have a new site that I'm going to allow you guys to have access to. It's free. It doesn't cost you anything. There's no membership. It's just technology-wise security. I come through and I just talk about the firewall capabilities and all that type of stuff that goes into it, and it allows you to come through. And as I'm creating more content on YouTube, it'll get mapped to here and stuff like that. So you guys will be able to come through and play around with the different technologies. So it's the YouTube videos, but in an organized fashion on the website. So longestmatch.weebly.com, I'll start to add that in there. And if you, I try to keep it as simple as I possibly can, for the sake of you and navigation purposes. There will be some other stuff, and I'll be putting out routing and switching and service provider. I plan on doing some of the content for each and going through the material, and going through all that type of stuff. So please check it out when you get a chance to. I will definitely be happy if you guys share this information out there. The description will be in the link below and stuff like that. Until next time, guys, thanks so much for stopping by, and we'll catch you in the next one. Take it easy, guys.